In episode 2, you installed Docker and ran a container someone else built. Today you build your own. We'll write a real Docker file, build a real image, and run a real container from scratch. And every command in this episode is genuinely executed, not simulated. A Docker file is just a plain text file containing step-by-step instructions for building an image. Each instruction, each line, becomes a layer in the final image, which we'll dig into more next episode. Docker reads the file top to bottom, executing each instruction in order. And the file itself is literally named Dockerfile, capital D, no file extension. For instructions cover most of what you'll write. From sets the base image, everything else builds on top of. Copy brings files from your machine into the image. Run executes a command during the build itself, like installing a package. And CMD defines the command that runs automatically when a container starts from your image. Let's use exactly these to build something real. Here's what we're packaging: a tiny C program that just prints a message. I've compiled it as a static binary, meaning it doesn't depend on any external libraries at all. That matters in a moment, because it lets us do something most Docker files can't: start from absolutely nothing. 3 lines. From scratch means we start from a completely empty image, no operating system, no shell, nothing. Copy hello/hello takes our static binary and places it at the root of the image. And CMD tells Docker, when someone runs a container from this image, execute /hello. That's the entire Docker file. This build output is captured from a real, live Docker build command. Docker reads our Docker file, loads the build context, the copy instruction runs as its own layer, and the result is exported and tagged as my first image, version 1. That -t flag is how you name and version your images. The whole build finished in about 0.2 of a second. 353 kilobytes. That's the entire image. Compare that to a typical image built from a full operating system base, which often runs into the hundreds of megabytes. This is the extreme end of what containers make possible. When there's no OS to carry around, your image is just your application and nothing else. And there it is, a container built entirely from our own Docker file, running our own compiled program. The --rm flag tells Docker to automatically delete the container once it exits, which is handy for quick one-off runs like this. Notice how instantly it starts. There's no operating system to boot, just your program executing directly. Let's recap what just happened. You wrote a 3-line Docker file. You build it into a real image using Docker build. You tagged and versioned that image as my first image, version 1. And you ran a genuine container from an image you built yourself, not one someone else published. That's the complete Dockerfile workflow at its smallest possible scale. One honest caveat: most Docker files you write day to day won't start from scratch. They'll start from a base image like Python, Node, or Ubuntu, which gives you a shell, a package manager, and standard libraries to build on. Scratch is the extreme minimum: no shell, nothing pre-installed. We used it today specifically so this entire demo could run with 0 downloads, fully self-contained. You can now write, build, and run your own Docker images. Episode 4 goes deeper into how image layers actually work and how to tag and structure Docker files properly. Episode 5 covers volumes and data persistence. Episode 6 is networking. And Episode 7 brings it all together with Docker Compose for running multiple containers as one application. That's Episode 3. You've officially built and run your own Docker image from a Docker file you wrote yourself. Subscribe so you don't miss episode 4, where we go deep on image layers. See you then.